So, a chemist has 1 liter, I give up on spelling, of 18 molarity hydrochloric acid. He needs 0.235 molarity hydrochloric acid for an experiment. Wow, I'm bad today. How much hydrochloric acid can he make? Well, first off, we start with our nice little equation. M1 times V1 equals M2 times V2. So we plug in our stuff, we get 18 times 1 is equal to 0.235 times V2. From there, we just divide out 0.235 over here. We get 18 over 0.235 is equal to V2, and 18 divided by 0.235 is equal to 76.6 is V2. So he can make 76.6 liters of hydrochloric acid. 0.235. Okay, you can go to.
Alright, so we have a very curious chemist, as Avery describes.
Very curious.
Very curious chemist, and he wants to know how many grams of H2O will be produced from 13.6 grams of C2H6 and 37.3 grams of oxygen. And he also wants to know what the limiting reagent is for that. Reagent. So first we're going to make the equation and balance it. So we know we have C2H6 plus O2 is C, and it turns into CO2 plus H2O because it's a combustion reaction. And now we're going to balance it, and since we have 2 carbons over here and we have 1 over here, we want 2, but I know that we have only 3 oxygens, so we're going to have to multiply these 3 by 2 so we can have a whole number here for the O2. So it's going to be 2, 7, 4, and 6, and that is balanced. So to start off with, we're going to start with the C2H6 to H2O. So we have 13.6 grams of C2H6 times 1 mole over 30 grams per mole, which is C2, or 2 carbon and 6 hydrogen equals 30, times the molar ratio, and you want the C2H6 on the bottom, so the C2H6 here and here cancel out, and the O2 on top, so it takes its place, times 18, which is C2 or H2O, over 1 mole, which is also, this is also grams per mole. And then when you do the math, it turns out to be 24.5 grams of H2O. And that's how many you get from using 13.6 grams of C2H6. So now we need to figure out how much we get from 37.3 grams of O2. And we do the same process, 1 mole over 32 grams per mole. This is so we can convert this right here and up here, is so we can convert it from grams to moles. That way we can use the molar ratio properly. And then it is 6 because of the H2O, like up here, and then 7 from the O2, times 1 mole on the bottom, because we want to go from moles, which is right this up, back to grams. over, and then another 18 grams per mole, and then from doing that we get 18. Maybe, do we get 18? Okay, let me do the math.
Clint done screwed up.
Whoops. I just want to make sure it's all right. Because, I don't know. 7.3.
Come on, Clint.
6 times 18 divided by 32 divided by 7. Oh, that's pretty cool. It is 18.0 grams of H2O.
I take back my statement.
Yeah, goddamn right.
I'm not sure if we can edit that out.
Oh well. I'm not even gonna be there for this. 2016, baby. So we got 24.5 grams from the C2H6, and we got 18 grams from the O2. So the O2 is definitely the limiting reagent. So what we're gonna do to find how much excess C2H6 will have, we're gonna start at 37.3 grams of O2 times 1 mole over 32, just like here. But instead of going to water, we're going to go to C2H6. So that is 2 instead of that. And times 30 over 1 mole. And this is grams per mole. Grams per mole equals 9.99 grams of C2H6. That's how much we will use of C2H6. So to find out how much extra, we're going to take our original amount of C2H6 and subtract it from this amount. And we get 3.6 grams of C2H6. For sig figs, you have, since we only have 1 past the decimal here, you can only go 1 past the decimal here. So that's why it has 2 and these ones have 3. And that's how you do that.